So first of all, I do want to say this is a tricky topic. So if you're learning iPhone programming, you're having trouble understanding memory management, you're not alone. There's no garbage collector on the iPhone, so you have to write the memory management code yourself. But unlike most other programming languages, your memory management code isn't 100% manual. Some of it happens automatically, but it's not 100% automatic. So it's a little confusing about this blend until you get the hang of it. Do read as many books and tutorials and papers as you can about memory management. It's the kind of thing where you need to hear from more than one author until you find someone who describes it in a way that makes sense to you. Additionally, in an iPhone program, you will see memory management using malloc and free because graphics libraries and things like that use some C programming. But in this presentation, I'm just going to talk about Objective-C memory management. So in Objective-C on the iPhone, all memory management is done using retain counts. Every object in Objective-C is derived from the base class NSObject. An NSObject has a property which is the retain count. The retain count is a count of how many other objects want to keep this object around. Or another way of looking at it is it's just a count of how many other objects have a reference to this object. You have to write the code that maintains the correct retain count. And you do that with two methods which are inherited from NSObject. So there's retain and release. So when you pass this retain message to an object to call the retain method, this increases the retain count by 1. When you pass the release message, the release method will decrease the retain count by 1. And the basic mechanism is that when the retain count reaches 0, Objective-C will delete the object from memory. So you write the code that maintains the retain counts, and when it gets to 0, Objective-C will then delete the object for you. When you first create a new object with alloc, that object has a retain count of 1. So if we look at this example, we've got an NS mutable string S1. We alloc it here, and then we initialize it. At the point that it's alloced, it has a retain count of 1. Now you can, in fact, see that retain count because there's a method on NSObject, which is the retain count method, which will return the current value of the retain count. So you can see here in this NSLog statement, S1 retain count is, and of course it's going to print out 1 in this case. Continuing through the example, let's say we then pass the retain message to S1. Well, retain increases the retain count by 1. It was 1, we increased it, so now it'll be 2. Then we pass release, retain count goes down by 1, and now the retain count is 1. Pass another release message, and the retain count goes to 0, so the object gets deleted from memory. If you pass the release message one more time, well, the object was already deleted, so that's going to cause the program to crash. So you create new objects with alloc, but there are also a few methods starting with the word new that create new objects, and there's also, you can create new objects with copy methods, and they start with copy or mutable copy. So for example, on NS string or NS mutable string, there's the method mutable copy with zone. So those methods of creating new objects, those are all cases where you get an object back where the retain count is 1. Now the basic principle in making all of this work is that if you create a new object, you are then responsible to make sure that object gets released. So if you create a new object, its retain count is going to be 1. So the object's going to stay around in memory forever until its retain count goes down to 0, and then Objective-C will delete the object. So if you create an object its retain count is 1, you're responsible to make sure its retain count goes down to 0. That's what it means by saying you're responsible to make sure the object gets released.